Lesson 8.3, multiplying polynomials. Our objective today would be multiply binomials using FOIL, and then also multiplying polynomials using distributive property. So this is Standards Algebra 1 6.4. The most common multiplying of polynomials ever is a binomial times a binomial, and you use the word FOIL, which stands for first, outer, inner, last. That's pretty universal. If you ask somebody that would be in high school, they're going to know what FOIL means. If you ask your parents, chances are, if they were any kind of did anything with math, they're going to know it. Some of them, they might just remember it because it's so widely used. FOIL, first, outer, inner, last. Okay, here's what that means. If I look at this binomial, y plus 8 times y minus 4, first means that you're going to multiply the first term in each binomial. So y times y is y squared. That's multiplying the first. Next, if you look at outer, outer means you look across the problem. There's 4 terms, the 2 on the outside, so y times negative 4. You multiply those outer terms, negative 4y. Inner, as you're looking across, left to right, across those 4 terms, the 2 on the insides, the 8 and the y would be 8y. And last, the last 2 terms in the binomial, so 8 times negative 4, negative 32. Most of the time, almost always, these 2 in the middle will be like terms. It's not 100%, but pretty close. So you should not leave those separated. In fact, anything you're ever doing from now on, you always combine like terms first. So your final answer here would be y squared plus 4y minus 32. We just multiplied 2 binomials using FOIL, first, outer, inner, last. So another example, example B, 2x plus 1 and x plus 6. First would be the first in each binomial, 2x times x would be 2x squared. Outer, looking across, the 2 on the outsides, 2x times 6, 12x. Inner, looking across from left to right, the 2 on the insides, 1 times x, I'm just going to write x. And last, 1 times 6 is 6. Again, the 2 on the insides, they're like terms. So 2x squared plus 13x plus 6. Okay, for this example C, I'm going to do something so that you can see what to do with it. I'm going to add, well, first of all, I need to scroll down a little bit. Is anybody still writing red? Anybody have any questions? I guess I kind of pushed through there. Okay, I'm going to add something to those binomials so you can see what to do with this situation. I'm going to add 5x minus 4y and 2x minus 8y, just to show you that it can be done. Okay? 5x minus 4y and 2x minus 8y. And I'm going to do the same exact thing I just did, FOIL. First, 5x times 2x would be 10x squared. My variables have to be lined up with like terms. I took 3a and distributed it through first for this first row. And I took 4 and distributed it through here for the second row. Now let's combine the like terms. 3a cubed minus 32a squared minus 45a plus 4. So you distribute 3a through that first, then 4 through its second. I lined up my like terms down below, combined them, put them in descending order of my variables so they were in standard form, and this would be my final answer. Questions about multiplying in that way? Any questions about that problem? Because I need to definitely clear it out to do the next one. Okay, so let's check out this next problem. A trinomial times a trinomial. Anybody want to guess how many times through I'm going to multiply here? Octavia?
3.
3. So here we go. 2b squared first. 2b squared times b squared. That would be 2b to the fourth, because the base of b is the same in both terms. Add those exponents. 2b squared times 3b. That'd be 6b cubed. 2b squared times 1. 2b squared. Questions on how I got any of those terms? I took 2b squared and distributed it through the second polynomial. All right, next stripe or row through would be taking 7b. So 7b times b squared would be what? 7b to the third. Where should I write it? Below 6b to the third. That would make it a lot simpler. 7b to the third. I'm going to be lining these up as we go. 7b times 3b. What would that be? 21b to the second. 7b times 1. 7b. And I'm done with that one. If you would ever have one term missing, like let's say it skipped from a fifth down to a third, there's nothing wrong with that. That's just the way it works out. Okay? Now we got to take 9 and distribute it through. So 9 times b squared is what? 9b squared. Where should I put that? Under the b squared column. So 9b squared. 9 times 3b. 27b. And 9 times 1. Thank goodness when you get to those constants, because you're done. So now see how everything's lined up for me? And I just start from left to right on this. My first term would be 2b to the fourth. My next term, what would it be?
13b to the third.
13b to the third. What about that next one?
32b squared.
Plus 32b squared. The next one?
34b.
34b. And the last? 9. Hey, what's the leading coefficient on this polynomial, Sophie? 2. And what's the degree on this polynomial, Ethan?
4.
4. You look for the highest exponent. That's good for that, and then leading coefficients the first term. Questions about that? All right, I have one application problem. Is anybody still writing red? I'll wait a second if you are. We good? Okay, one application problem here. At the bottom, it says to find the area, and it's got the area formula there, but you might need to know this on your own, but I think you all do. Area is 1/2 base times height. It gives you the base and height in terms of polynomials, in fact, binomials. So the area of this triangle would be 1/2. The base would be 6x plus 4. The height, what's the height? X minus 7. So polynomial, or I should say binomial times binomial, we're going to use what? FOIL. FOIL. So first, 6x squared. What's my outer? Outer would be 6x times negative 7, negative 42x. Inner, 4 times x. And last, minus 28. Okay, so before I apply that 1/2, I'm going to simplify what's in there. So 6x squared minus, I believe, be 38x minus 28. Okay, I'm not done. I've got to apply 1/2 through there and distribute it. So if I apply 1/2, 3x squared minus 19x minus 14. It didn't give me any units, so how do you think I should answer? Units squared. Units squared. Okay, that's a very good application problem there. All right, questions about that? Great.